Okay, problem 88, we've got a average value problem. Now, this is a tricky one because it says average rate, okay, and you're going to think of average rate as average rate of change. However, what we're integrating is a rate. So when we talk about the average rate, whatever goes here, when we do this, gives us the average, okay, of this. There's a really cool example I'm going to show you guys in class in the next couple days about integration and average rate of change. Let me just write that dx there. So if we actually sort of read this using English syntax, during the time interval 0 to 4, what is the average rate of water flow? Well, 0 to 4, this gives us our average, so this will signify average. Well, average what? Average rate of water flow. So we would put this right here. Why do we put R of t there? Because that's the rate of water flow. So rate of water flow, average. Rate of water flow, average. And the average comes from the full integral and dividing by the limits there. If we were to simply do, for example, R of 4 minus R of 0 over 4 minus 0, well, this is actually going to give us essentially the second derivative, which is not what we want. It's going to give us the average rate of change of a rate of change. Does that make sense? So, well, I just asked a question to a video, but you guys get the point. This will give you a rate of change based upon not already having a rate of change. We have a rate of change, and we just want to find the average of that. So we integrate that rate of change and divide by those bounds. So let's go ahead. I'm going to pause this and write the calculator syntax. Okay, this is what I type into a calculator. Now, this actually does not give me the right answer because what I did for mine, when I typed this in, I got 58.7642, and I need to divide that by 4. That is a square root right here. Notice that in the function, I was given t, but I'm always using x when I'm on a calculator. That's an x right there. It's absolutely hard to write. And I go ahead and I do that and divide by 4, and I get 14.691, which is this value here. Should definitely do some average value problems on your own. They pop up on free responses often, especially the Riemann sum problems, and you'll get a point often for just memorizing, hey, average value on a Riemann sum, what to do, but they're going to tell you how to, what does it mean in the context of the problem, can you interpret it, and really just want to put the two things together. When you're doing the average and you know that you're doing it, well, just say that that's the average of whatever this is. Okay, and it's not always a rate. But in this case, this was the average. What? Well, what was R of t? If we read it, it says right here, let me highlight this, the rate in which water is sprayed on a field of vegetables is given by R of t. So this is the average rate at which water is sprayed on a field of vegetables. Or you could call it the average rate of water flow. Okay, hopefully that explains some things, and we will see you back for problem 89.